All right, welcome back, Cibola math analysis students. Today we're going to go ahead and do review number 3 on how to solve radical equations. And the way we're going to do it is we're going to isolate the radical, the square root, if you would, and then remove the radical using an exponent. So when you isolate something, you try to get it by itself. So this is our radical right here, the square root of the quantity x plus 3. I want to isolate this, get it by itself. So the first thing I want to do is get rid of anything else that's not inside the square root. This negative 4. The way I do it is just like you always would do. Just add 4 on both sides. It cancels out the negative 4. You still have the square root of x plus 3, but now on the right side it equals 11. You have now isolated the radical. Most of you know what to do next. If you want to get rid of the square root, the inverse of the square root is a square. The exponent that we call a square is taking it to the second power. And so if you square a square root, their inverses, they cancel out. What you get left is just what's inside. That's called the radicand, x plus 3. On the right side, 11 times 11 is 121. Subtract 3, and you're done. X equals 118. It's not that bad. So the steps are to isolate the square root, the radical, and then use an exponent to remove the radical and solve whatever's left. Now, if you plug this in and check the answer, we can make sure it works. I'm going to go ahead and do that right now. If I try this, basically if x equals 118 and you add 3, and you take the square root, take away 4, you should get 7. Well, let's see if that works. You get the square root of 121, which is 11, and since I went to elementary school, I know that the square root of 11 minus 4 is 7, and 7 equals 7. It works out. So I know that this answer works, and we always want to check our answers when we're solving radical equations because something will happen sometimes where we get answers that don't actually work. Let's move on. When the answer doesn't work, there's a name for it. It's called an extraneous solution. That's a solution that's not really a solution to the original problem. You might find it as you do the work to solve it, but it doesn't actually solve the problem. So if you take a look below, it says find the mistake in the problem. And I'm going to go through it step by step, and we're going to see if we can find the mistake. So what's in the yellow box is the problem. It looks like the square root is isolated, so we're going to go ahead and square both sides by putting an exponent of 2. And so when I do that, the square root of x plus 2 just becomes x plus 2. If you use FOIL, or just squaring the right side, you'll actually get this, 16 minus 8x plus x squared. Remember when you use FOIL, you're multiplying the binomial times itself. And so 4 times 4 is 16, 4 times negative x times 4, and negative x times negative x. And there is a shortcut to this. If you're not aware of what that is, don't use it. Just use FOIL. And so, yeah, that step was fine. Let's see what else they did. Looks like they subtract 2 from 16 and get 14. Yes, they subtract x from negative 8x and get negative 9x. That works. They put this in descending order. They just rearranged it. That was fine. The factors look right, and so they get 7 and 2. I don't see a mistake in the work, and there isn't. So, knowing that the work is correct, why does it say to find the mistake? Well, I kind of hinted to it at the very top. What's an extraneous solution? It's a solution that's not actually a solution to the original equation. So we're going to try x equals 7. Does it actually work if I plug in x equals 7? So if I do the square root of 7 plus 2 equals 4 minus 7, again, I'm just plugging in x equals 7. Does it work? Square root of 9 equals negative 3. Does 3 equal negative 3? No. 7 doesn't look like it works. Let's try 2. The square root of 2 plus 2 equals 4 minus 2. So I get the square root of 4 equals 2. 2 equals 2. Yes. Okay? And so 7 is an extraneous solution. We're going to cross it off. Okay? And so right here, it's extraneous. Okay, it's an extraneous solution. The only one that works is 2. The answer should only be x equals 2. And so that's one step you're going to want to do. You always want to check the answers, make sure they solve the original equation. You might get an answer that works when you do the math, but when you try it, it doesn't actually solve the original equation. So always check for extraneous solutions. All right, if you want to check if you're understanding everything, you could try this problem. I'm going to go ahead and solve it for you, but you could pause the video and try it yourself and see how you do. So first thing we want to do is isolate the square root. Means get it by itself. The way we do that is just subtract 4 from both sides. And so what I get is the square root of 2x minus 5 equals the quantity x minus 4. Okay. Once you do that, you're going to need to get rid of the square root by putting an exponent of 2 on both sides. When you square something like this, it cancels the square root. You get 2x minus 5. On the right side, I'm going to show you a shortcut. If you've used this before, when you're squaring a binomial, you can square the first term. X times x is x squared. You can multiply x times negative 4 and then double it. That's a shortcut. So x times negative 4 is negative 4x. Double that, it becomes negative 8x. And then square the last term. Negative 4 times negative 4 is positive 16. If you don't like that method, just use the normal FOIL method. It'll give you the same answer. Last thing we're going to do is we're going to subtract 2x on both sides and add 5 to both sides to let one side equal 0. X squared minus 10x plus 21 is what we get. This will be able to be factored. It's x minus 3 and x minus 7. And so if those are our factors, the solutions that are potentially correct are x equals 3 and x equals 7. Before you say, okay, well, that's the answer, I'm done. I'm so proud of myself. Check the work. See if those solutions actually work. If I plug in x equals 3, it should solve this equation. So it's 2 times 3 minus 5 plus 4 equals 3. Does that work? Let's find out. So 2 times 3 is 6. 6 minus 5 is the square root of 1. Is the square root of 1 plus 4 equal to 3? 1 plus 4 does not equal 3. Okay? No, that's wrong. I know that x equals 3 is extraneous. So I'm going to cross this off. This one's extraneous. Okay. And so I still need to check x equals 7. It's possible that neither one of these work, but let's try x equals 7. Hopefully it works so we get an answer. All right, so if I try this, I always want to plug it into the original equation. I get 14 minus 5 is 9. Okay, a lot of you can do this in your head, but basically you end up getting 3 plus 4, 7 equals 7. That works out good. So there is one answer, x equals 7. If you had a problem where both answers cancel out, there's two extraneous answers, there's nothing else, there'd be no solution. But most of the time we end up getting at least one solution. We could actually get two solutions, it just depends on the problem. Always check your work, make sure the problems actually work out. So you always want to isolate the square root, the radicals, if you can, because then you only have to square things once. I want to show you what happens when you can't isolate the square root. It's not fun. Okay? So let me go ahead and show you. If you look at this one, it might look like it got a lot harder because now there's two radicals. That's actually not the problem. It's this number right here, this negative 1. Because of that, if I were to square both sides without that number there, I could just get rid of the square roots. Okay? If I didn't have that negative 1 there, if I squared both sides, the square roots would cancel. But because that negative 1 is there, you're going to see what's going to happen here. So you can't isolate the square root. You just start by squaring both sides. Okay? But here's the problem. When you square the square root of x plus 3, you get x plus 3. What happens when you square this on the right side? Okay. Well, I'm going to show you what happens. You're going to use FOIL, and I'll show you the steps here. It's the square root of 2x plus 8 minus 1 times the square root of 2x plus 8 minus 1. Some of you are already going to see that this doesn't look like fun. You have to distribute using the distributive property. So you end up getting this. If you distribute this times this, the square root of 2x plus 8 times the square root of 2x plus 8, the square root cancels out, you get 2x plus 8. But then you get minus, because you do square root of 2x plus 8 times negative 1, it becomes minus the square root of 2x plus 8. Then you do negative 1 times the square root of 2x plus 8 again, and you get minus the square root of 2x plus 8. And finally, negative 1 times negative 1 is positive 1. It's really that much work. We can try to combine like terms at this point. And so what I'm going to do is on the right side, I'm going to combine things together. So I'm going to have 2x, the 8, and the 1, I'm going to put plus 9. And since these are both the same, they're both negative, I'm going to say there's 2 of them. So I'm going to do minus 2 times the quantity of the square root of 2x plus 8. Just combining like terms. I can then get rid of the 2x by subtracting 2x. I can get rid of 9 by subtracting 9. It helps me simplify this a little bit. This would cancel out. I get negative x minus 6 on the left side, and then negative 2 times this on the right side. Well, to be really honest with you, there's one more step we're going to do. We're going to kind of pretend we started here. You could divide by 2, or divide by negative 2 if you want, but it doesn't help because to me that just makes fractions. It makes it more work. Let's just square both sides right now. And again, if you're a little bit lost, just know that these problems are the most difficult of any of the radical problems. The one I'm showing you is basically as difficult as it gets. And so we're going to square both sides. And what happens here when you square, like negative x times negative x is positive x squared. Negative x times negative 6 is positive 6x. And you double it, you get plus 12x. Negative 6 times negative 6, positive 36. On the right side, negative 2 times negative 2 is positive 4. And then you square the square root, and you basically just write it in parentheses. You get rid of the square root, and so it's just the quantity 2x plus 8. Then we're going to distribute the 4. Okay. And then from here, we're just going to subtract 8x, subtract 32, like we normally would do. The hard part's done. So you can take a breath. You did it. If you've been following along and it's sort of made sense, that means you're doing good. All right, so I get x squared plus 4x plus 4 equals 0. I'm going to work it out up here now. So I get, if I were to factor this, what numbers multiply together to equal 4 that add up to equal 4? Well, it's just positive 2 and positive 2. The answer is just x equals negative 2. Okay, they're both going to equal negative 2, so that's it. I need to check my solution. Does it work? And so just to check, always in the original equation, negative 2 plus 3 equals the square root of 2 times negative 2 plus 8 minus 1. So this is going to be the square root of 1 equals the square root of 4 minus 1. So does 1 equal 2 minus 1? 1 equals 1. We're good. We did it. It has one answer, and the answer is x equals 1. So I hope this has been a little bit of a review. I know some of you are still really worried about what if this is on the test? How will I be able to do it? Again, there's lots of videos. You can just search solving radical equations on YouTube. I'd be happy to go over some more. I have some more examples we can go over if you come to the Google Meet. The ones I had planned on doing today, but we won't do them, are these ones. So I was going to go over these. But they're not too hard. They're actually pretty basic. I think if you do have questions, it might be something like this one, number 3. And so we're going to end it here today. Thank you for watching. Please copy these notes.